Hello everyone, myself I am Dr. Parves Mohammed, working as an assistant professor in Marri Reddy Institute of Technology and Management, Hyderabad. So today we are going to discuss about data science subject. In the data science subject, what are the various types of data types and the statistical descriptions of the data. So in data science subject, it is consisted associated with R programming, and in R programming we have various types of data types. So data types and their statistical descriptions. What are the basic statistical descriptions and what are the various types of data types that we are going to discuss in today's session. So here there are various types of data types, as we know. If you look after programming languages, in programming languages there are different types of data types, like C language. If you take C language, in C language we have integer data type, character data type, float data type, or double, long integer, short, signed, unsigned. There are various types of data types in programming language. Okay, however, how like we have C language data types, here also in R programming, which is consisted with the data science subject. So in R programming also we have various types of data types. The very first one is numeric data type. As you know that a numeric data type is a data type that is consisted with various types of numerical values, which accepts different types of numerical data, a number based data that can be accepted by the numeric data type. Okay, so here I have given 2 points, integer and floating point. An integer is a data type which accepts numbers, as well as a floating point, that also real type of number, real numbers, real values can be accepted in the float data type. So the integer data type and float data type, that is there in the numeric data type in R programming. The very second one, that is character data type. Character data type is a single alphabet that can be accepted, okay, or a group of alphabets that represents a text. Okay, of course, in we can say that it's a string, but in R programming, the character data type alone it accepts single alphabet as well as group of alphabets. So right now we are in data science subject. In data science subject we have R programming. In this R programming, the character data type which accepts text as well as single alphabet. Okay. Then the third one we have logical data type. The logical data types are which accepts true and false values, that is also called boolean values. A boolean value data that is associated with the logical data type. And then we here I have given as logical data type as true and false. True and false, yes or no, okay, or any type of 1 and 0 number, that also can be represented for logical values. It is also called binary values. Then here we have factor. A factor data type that represents the categories. Whenever you represent the data in various categories, example, gender specification. In case of gender specification, we will categorize the gender as male or female. Okay, so in that gender specification, we will declare this factor data type. A factor in R programming, a factor is associated, accepts with various types of categories of the data. The different categories of the data is associated with the factor data type. So you just remember that factor is nothing but categories, the data representations, categories of the data representations, like true or false, okay, yes or no, salary received or not, fees paid or not, gender, yes, male or female. Any one category we have to choose. From the given 2 categories, any one we have to select. Now in the case of gender, here I have given example as gender, male or female. If I write male here, if male is called true, then the female will be false. If this is case 1. In case 2, what happened? In case 2, for example, male not there. For example, male is false, then female is called a true. So here what we are doing here, either we are working with a male or else we are working with female data. So any category, any one category we have to choose. Whenever we choose a specific one category of the data, that is called a logical type of data. It is a logical type of data. This logical type of data is a property of factor. So factor is a basic data type in R programming which represents categories of the data. While we are representing categories of the data, we will declare factor. Clear? And next, another data type we have, that is called list. List meaning having the definition. While you are declaring group of elements or group of data or group of some values, that comes under list data type. A list data type is a collection of elements. Clearly it is given. It's a collection of elements, the group of elements. Okay, so all this group of elements belongs to be one data type. They must be belongs to one category. Either you have to choose all numbers. For example, here I have given all numbers 83612. Either we have to select all alphabets. Okay, we have to go with all alphabets, or either you have to go with all percentages, 2.0, 3.0, 4.0 decimal values. So one category of the data we have to choose. While you are choosing a specific category of the data, that comes under list. So list is the data type, one type of data type. Next, another type of data type we have, that is called matrix. Matrix being meaning having the definition. In matrix, we represent the data in the form of row and column. That is also called a tabular structure. Okay, it is also called an array, two-dimensional array. So whenever our data is represented in a tabular structure, whenever we represent the data in a matrix form, then we will say that it is a matrix category of the data. That is, a matrix is consist of rows and columns. So the data can be represented in the form of rows and columns. Usually rows and columns data is nothing but tabular structure. It is called a tuple. So in data science, in case of R programming, we are saying that the matrix form of data is a two-dimensional data which is related to arrays data, which is also called as a table structure data. That is the meaning of matrix. And next here we have data frame. Data frame. This is one of the important concept. It is one type of data type, of course, but we have a special concept on this data science, that is called data frame. So a data frame is what? A data frame is nothing but whenever you arrange the data in a specific order, whenever you frame the data, you arrange the data in a row and column structure, and whenever you represent the data in a tabular format, as I told you just now, matrix data is a array data. There we have 2 cross 2, 3 cross 3, such that type of matrices. Here in the data frames, here we have a data frame in a table form. Purely it is in the form of table structure. A table structure represents what? A table structure is having different types of entities and different types of records. We have entities as well as we have records. So entities are nothing but field names, and records are nothing but the data what we are writing in the respective field names. So whenever you represent the data in this table structure, now you can say that this table is a data frame. It is a data frame. So this data frame belongs to the table structure of the data. That is the meaning of this data type. That is called data frame. Okay. Next, we have some basic statistical descriptions of the data. Okay. All the statistical descriptions are data which is purely dependent on three values. That is called mean, median, and mode. Mean, median, and mode. Mean is nothing but sum of all values which is divided by the total number of values. That comes under mean. Median is nothing but the medial value for the given set of values. There are some set of values. The middle value we will consider as the median value. And mode. The mode value, the most frequently occurring value in the set of values. While you are representing the set of values, okay, while you are representing the set of values, here the most frequently occurred value. Which value is most frequently occurred? 6 is most frequently occurred, 2 is most frequently occurred, and 1 is most frequently occurred. So we'll write like this, 6, 1, 2. What is this? The representation of most frequently occurred value. Whenever you write a set of values, in that set of values, a particular value which is frequently repeated. That frequently repeated value is called as the mode. Okay, that's the meaning of mode. Then here variance, and we have three more types, not only mean, median, mode. We have variance is there, standard deviation we have, and percentile we have. A variance is what? A variance is a value that measures how far each value is the set of for the given mean values. In the given mean values, how far the value is occurred, how far the value is given, how much values you have given, whether you have given some set of values or more set of values. Whenever you represent this how far values, in that case we will go with variance. And standard deviation, standard deviation is what? The root values. Whenever you represent the data in the form of root structure, this root type of values, for example I have given root 8, so value is there, the standard value we can identify by with the help of root values. So root is given, the root value is given. For that root value, the square root value is the variance of the measuring average or the total amount of value that comes under standard deviation. And another one we have that is called percentile. In this percentile, the value below which is the percentage of the given values. For the given set of values, whenever you identify the average of the value or whenever you identify the percentage of the value, that comes under percentile. Okay, next the same concept, the under the concept of statistical descriptions of the data, the statistical descriptions of data which is also works with not only mean, median, mode, but also works with various types of attributes and central tendency. The discrete values, different types of attribute values that can be represented in the central tendency for measuring statistical descriptions of the data. So describing attributes by number of values. How many values we have given? For all that number of values, we are going to describe the attributes and their number of values. So in data science, what happened? In data science, an attribute can be represented with the help of analysis of the data, statistical descriptions of the data, or you can say that an attribute that can be implemented to represent a diagrammatic form of the data. If you are declaring an entity, for that entity, we may declare different types of attributes. While you are declaring different types of attributes, that attributes defines the characteristic. It is the characteristic or it is the behavior of the data. Maybe it is a characteristic of the data or maybe it is a behavior of the data. So the behavior of a specific entity type, the behavior of a specific data, that can be represented as the attribute. So an attribute that can be implemented with various types of behavior or characterization of the data. Okay, then here we have some types of attributes. Here basic three types are there. We have so many types, but basically three types are given in this slide. Then we have other more types also. Furtherly, they have so many other types. The first one is a nominal attribute, and the second one is ordinal attribute, and the third one is interval attribute. Okay, we have some other attributes also, binary attribute, numerical attribute. Okay, and other types are also there. But first, basically, I have categorized three attributes. The three attributes are nominal, ordinal, and interval. In case of nominal attribute, what happens? In case of nominal attribute, it represents a nominal attribute that are having finite number of unordered values such as gender or hair color or categories of the student, categories of a specific field. For example, gender. Here gender is given. In this gender case, what is happening? Male, female are the two representations. In this male, female, we are identifying the gender specification. For this gender specification, we will say that either male or female. Or second example I have given as hair color. I have selected three colors: black, brown, and blonde. Usually we have black and brown. Okay, so if I select black color, then the brown color will be false. Brown color is called as a false because I have selected black color. So the black color is called what? It is true. Yes. If black color is true, then the brown color will be false. For example, in case 2, brown color is true. I have selected brown color as true. If brown color is true, then we will say that black color is false. Why? Why it is like this? While you are representing nominal attributes, you have to choose any one category of the data. When we are choosing a specific category of the data, from the given 2 or 3 categories, if one category is success, the rest of categories will be failure. Clear? For example, gender, as we discussed previously in the data type section, gender, male, female, 2 examples we have given. We consider as male field name, then the male field name is called true and female is called false. In second case, we considered female is true, then male is called false. Why? Because from the given 2 categories, one category is going to be true and the second category is going to be false. That representation is also called as the nominal attribute. Okay. Then we have ordinal attribute and interval attribute. In ordinal attribute, what happens? In ordinal attribute, the set of values, the number of ordinal values such as high school, low school, high school or middle school or primary school, this type of categories I have given. I have selected example as education levels of the education. In the levels of the education, I have categorized as through 3 columns. First one high, second one high, middle school, primary school. This is one example. Total education system we have selected. The total education system having high level study and college, high school level study, high school level study, college level study, then postgraduate level study. First high school study, then college level study, then postgraduate level study. So what we are doing here? We are not choosing any one from the given 3 values. We are moving forward one after another. For example, first school level data, school level study, you are processing school level study. After that, we are going to the college level study, that is called second category of the data. Then you are going to the postgraduate study, that is the third category of the data. Okay, if you look after only one structure, one case, that case is called school level data. If you look after only one case, that is called school level data. In that school level data, primary school data, middle school data, high school data, 3 categories. Now the decision is ours. Either you can go with 3 categories of the school levels, or we can go with 3 categories of the entire study. Our entire study is categorized as 3 levels, or school level studies categorized 3 level. So you choose any one. The concept is what? The concept is you have to complete, you have to pursue and complete all the levels. You should not go with any one level. Whenever you are choosing and pursuing all the levels one after another, that comes under ordinal attribute. Okay, that is second one. And interval attribute. An interval attribute defines what? An interval attribute that works with works with numerical values, temporary values, degrees values, Celsius values, fixed values. For example, room temperature, I have given, for example, 30 degrees. This is what? A fixed value. 25 degrees is a fixed value. The ratio, while you are calculating the ratio, while you are calculating the percentage, we will get some fixed values. In that case, we have to say that it is a interval attribute. That is the meaning of third category of the attribute type. And next we have ratio. Just now I said ratio data type is also there. In this data type, the measuring of height, weight, the different types of measuring central tendencies, kilograms, specific height, specific kilograms, specific weight, kgs. Okay, kgs are tons, quantity of the rice, quantity of the products, quantity of the particular things, quantity of the items. For example, we have ordered some items, 2 items we have ordered, 3 items we have ordered, 1 item we have ordered. One is also one type of specific number which represents a quantity that comes under this data type. Okay, and knowing with the different types of values, you may work with all these values in data science. Specifically in R programming, we work with a nominal attribute, we work with ordinal, we work with interval attribute, and of course we will work with ratio, calculating the ratio, percentage, calculating the average. Okay, height and weight. What is the height of the student and what is the weight, divided by, calculate how much value will get. That called one type of ratio of the specific representation. So a ratio also can be represented. Okay, next we have asymmetric attribute. An asymmetric attribute that work with in data science, it works with various types of values. For example, if you consider positive value, negative value, if you look after some data, for example, we will take one example here. The example is medical data. I am selecting medical data. In this medical data, what happens? While you have given a sample of a blood, okay, while you have given a sample, the entire report can be displayed in a specific format. Means, for example, in body, glucose level we have to maintain, okay, less than 200, greater than 100, for example. This is a range. Now, what value you got? Range is given. What value we got for in our body? How much glucose value is there? How much blood percentage is there? So we will calculate. We will check. We will look after. How we will look after? How we will calculate? How we will come to the notice that what is there, whether a disease is there or not? How we will notice? We will notice. We will identify by taking some values, by taking some a representation that is called table structure representation. That table structure representation data is called asymmetric attribute data. It is asymmetric values. Okay, so in this asymmetric values, what we have? We have clear report. We have clear data. In that clear data, how much values are there? How much we have to get? For example, 100 to 200 is the average. 100 to 200 is the average or normal person of the glucose level in the body. I got 180, for example. So this 180 value is where it is less than 100, it is greater than 200, it is in between 100 and 200. For example, it is 100 and 200. Then it is called a success. That is called normal value. No, beyond that we got. Then we will say that, yeah, so and so disease is there, our blood level is so and so less, or this is like this, like that, we'll calculate. So how we are coming to the, how we are justifying this data means, we are justifying this data by with the help of specific attribute data. Already the specific attribute data is given. For that specific attribute data, we are calculating. Next, binary attribute. As you know, binary attribute meaning having the definition, a binary attribute in data science that can works with representation of 0 and 1. 0 means will represent as false, 1 means will represent as true. Okay, while you are representing binary attribute either with a 0 or with 1, we have to proceed. Okay, here some examples are given. Gender male 0, female 1. Okay, loan approved, second example. Loan approved 1, rejected 0. So we will categorize the data for binary attribute. Binary attribute is nothing but either with 1 or else with 0, we have to proceed. Okay, then customer segmentation. High value customer 1, low value customer 0. If high value customers are there, that high value customers are represented as 1 and the low value customers are represented as 0. Okay, next, nominal attribute. As I told you just now, categories of the color. What I said, categories of the color. Nominal attribute is an attribute, type of attribute in data science that describes categories or labels of the data rather than the numerical values. Instead of going with numerical values, if you are going with categories of the data, that comes under nominal attribute. Here 3 examples are there. Example 1, color category. In that color category, some types, red, green, blue, yellow, etc. That comes under various categories. A specific entity which is representing various categories of the data. While it is representing various categories of the data, that comes under nominal attribute. Previous slide, I said that red color, hair color, okay, black and brown I have given. Such that way, the categories of the data can be represented. Nationality, Indian or American or Chinese. Who are you? Representing the nationality. That comes under category. Occupation, what is your occupation? Teacher, engineer, doctor. Okay, we represent a specific one category of the data only. That category comes under the nominal attribute data. And next, ordinal, as I told you, high school data, low school data, high school, primary school, middle school, high school data. If you consider a specific school data, in that school data, primary children's data is one side, middle school data can be considered in another side, high school students are there, 8th, 9th, 10th high school students are there. So that data is also considered as one type. So an ordinal attribute that can be represented with the categories of the data. 3 examples are given here. I have given 3 examples. First one, education level. Second one, customer satisfaction. Third one, movie rating. First one, education level. High school, bachelor's degree, master's degree or PhD. High school of the data. Okay. Bachelor's degree data. Okay. Postgraduate data. 3 categories of the data. If you look after these 3 categories of the data, then it is a education level of the data. Then we have customer satisfaction. While you are purchasing a specific product, we have to give a feedback or we have to give the customer satisfaction. Either from 1 to 5 points will be given. Okay, 1 poor, second good, third very good, fourth excellent, 5 outstanding. So one category we will choose, one category we will nominate a category of the customer satisfaction scheme. Under the customer satisfaction, we'll give one category, either 1 number or 2 number, 3 or 4 or 5 number. That also comes under the ordinal attribute data. And movie rating is the new example. Movie rating, poor, fair, good, very good, excellent. Poor movie, average movie, good movie, very good movie, excellent movie. So whenever you represent movie names in different types of orders, that comes under categories of the data. Okay. Then basic statistical, as we discussed just now, basic statistical descriptions of the data is purely dependent on mean, median and mode. The mean value, median value, mode value. If you look after mean value, mean is equal to sum of values by number of values. All the sum of values, the different types of sum of values, total number of values and a numeric number of values, total number of values. Specific sum of values divided by total number of values, that will be calculated in the mean. Median is the middle most frequently occurred value. Most frequently occurrence of the value is comes under median. And mode, the most frequently occurrent value is set of value in a data science, that comes under median point of view, the most middle value of the specific set of value, most frequently occurrent value comes under the mode. Okay, and measuring decision descriptions of the quantifiable. Here we have a new term that is called quartiles. QUARTILS, quartiles. So in this quartiles, what we will do? We will categorize the data in some categories, some specifications. For example, Q1, Q2, Q3. I am dividing the data into 3 categories. Q1 category, Q2 category, Q3 category. In Q1 category, I am taking 25% of the data, for example. In Q2 category, I am taking 50% of the data. And in Q3 category, again I am taking 25% of the data. So when I am taking the data into different categories, when I am taking the data into various categories, and when I am representing this data as in the 3 or 4 category structures, then it is called a quartile data. It is called a data quartile. Now you see the definition. The definition: quartile measures of descriptions that summarize the descriptions distribution of the values in a data set by dividing the data into 4 equal parts or 3 equal parts. As I told you just now, whenever you have taken total amount of data, and the total amount of data you are categorizing into 3 or 4 categories. Consider as I am taking 3 categories only. For that 3 categories, I am giving 3 names: Q1, Q2, Q3, and I am dividing the data in an exact form. Like first category Q1, 25% data. Second category Q2, 50% data. Third category Q3, 25% data. Such that way, the total amount of data will be 100%. So whenever I am categorizing the data in a specific order and I am implementing processing the data, that data is called as a quartile data. In data science, it is a quartile data. Now you see this example. Same example is there here. Q1 25%, Q2 50%, Q3 75% given. In that 75%, 25% of the data is called used data. Remaining 50% data is called waste data. If you have taken more number of data, more than the beyond the boundary, if you have taken more quantity of the data, then we will say that in that specific amount of data is called used data, and the rest of the data is called unused data. So Q1, Q2, Q3, 3 categories are there. In Q1, 25% of the data can be considered. In Q2, 50% data can be considered. In Q3, 75% data is there. In that 75% data, we will undertake 25% of data only. Rest of the data is the waste data, which is not at all useful for our organizations or for our table. Clear? So that is there. Here it is there. Clearly it is given. 25% high values can be processed. Rest of the 50% data cannot be processed. So total data is categorized into 3: 25% data, 50% data, 75% data. In this is Q1, Q2, Q3. In this Q1 25% data processed, Q2 50% data processed, Q3 75% data is there. In this 25% data processed and 50% data can be removed. It is not used. It is called unused data. If you look after this unused data, then only it is correct. Otherwise, again, it is a problem. Again, it can't be processed. Okay. So this is the meaning of quartiles. So quartile data can be processed in different categories of the data. Next we have quartile summaries. Q1, Q2, Q3. You may ask like this: why we are not going for 4 or more categories? You can go for 4 categories also. Q1, Q2, Q3, Q4. If you do like this 4 categories, exact percentage you have to declare: 25%, 25%, 25%, 25%. You have no choice to increase or decrease the processing percentage of the data. Okay, so that's why I'm not going with 4 categories of the data. I'm working with the 3 categories of the data only. So in these 3 categories of the data, what happened? Q1 is selected, Q2 is selected, Q3 is selected. In Q1, exactly 25% data I have processed. In Q2, exactly 50% data I have processed. In Q3, I have taken 75%, but in that 25% I have processed, 50% I did not process. Why? Because, okay, this is the space, 100% space. Here first Q1 25 over, second Q1 50% over. Then we have only 25% space only. In that 25% space, what I am doing? I am adjusting, I am implementing, not adjusting, I am processing exact 25%. Rest of the percentage data I am removing. That comes under waste category of the data. Such this way, the entire 100% of the data can be processed in data science. This is the meaning of quartile and range. This is called quartile and range of the data processing in data science. Clear? So this is about the entire quartile and range. Okay, I hope you understood. This is about the data types, okay, the statistical descriptions of the data, and various types of attributes also we have discussed in this session. Clear? So I hope you have understood. This is about the today's session. See you some other time. Thank you.